Hi everyone, welcome back. If you would like to press like before you forget, that would be wonderful. Here we go. In the assessment I just had, the exam I just had with my Year 11, what we call a methods class here in Australia, I had so many students get this wrong. This also happens to be in our Year 12 applications course here as well, and saw so many students get it wrong as well. People get mixed up between two systems, and there are two systems involved when we're talking about arithmetic progressions. Now, arithmetic progressions just means it's going up by the same amount, like you're going up by 2, going up by 2, going up by 2, starting at 5. Now, I could write another set of numbers that went up by 2. If I went to a different coloured pen, I could say I have 10, 12, 14. So where you start from is crucial. And you get student after student after student over the years who doesn't write down where you start. So I talk about recursive having 3 T's. Talk about lots of ideas about recursive. It just means they're recurring at the same pattern. And the way they're recurring in this question is we go and add 2, add 2, add 2. So the recursion is adding 2 each time. So first thing, give you a rule. The first rule is always write down the first term. And the first term in this one would be 5. Whereas over here, the first term would be 10. And of course, over here, the first term is going to be 100. So when you use a recursive, you must state the first term. And I'll put a box around it and nag about it and say you must write the first term. So if you wanted a pattern to get into or a rule to get into, always write the first term. If you're confident, you don't need to because you won't forget to do it. But it still amazes me how many people forget. Let's have a look at what's happening. So we have this weird system called Tn plus 1. Interesting, when I was back at school, we used to use U. Don't know why we use U, but nowadays we use T for terms. A lot of people use A. So I think it's more common sense to use T, but if you see people writing as A, or on our class pad calculators, you'll see it written as A as well. So this idea here is about to get the next term, we get the previous term, and we're going to do something with it. So to get the next term, you get the previous term, and what did we do to 5 to get the 7? And you can look at there and you could just go, I went plus 2. So if I wrote there that we went plus 2, even though I wrote in a red pen. So you start with a term, any term, like 5 in this case because it's the first term. How do we get the next term? So to get the next term, you get the previous term and you add 2. Now some people will write this as Tn and Tn minus 1. I'm not going to do that for this video because it gets too long. So it doesn't matter which way you write it. Now I talk about this having 3 T's. So there's the term for the first term, there's for the next term, and there's the previous term. So you end up with 3 T's. If you do Fibonacci numbers and Lucas numbers and other systems, or even just something I could make up, you can end up with 4 or 5 T's. But the basics to get people working on it is to write the 3 T's and write the first term. I'm going to go over this one over here. And we know that the first term is 100. So I'm going to write that term 1 equals 100. Going to circle it again and nag about it again to write down that you've got to get the first term. Write the first term down. Same principle like always. Next term equals the previous term. Now this time, instead of adding, we're subtracting 5. Every time we're subtracting 5. Now we're not talking about prove it's an AP or prove it's a GP. It's just saying give us the recursive rule for it. Now, in the wording of the question, if it does not say recursive, you do not use this system. You only use this system if it's irrelevant which system you use, or you know that the question says it's recursive. We'll go to the formula in a second to show you the other types of questions. So in this one, each time we're going to subtract 5. Now, that's our recursive. So if I picked any number, for example, let's start with 100 in this case. How did I get 95? To get the next term, I'm going to nag a fair bit about it. You get the previous term. So if your previous term was 100, you subtract 5 with it from it, you end up with the next term, which is 95. And if you have 95 and you want the next term, so you're starting at 95, you subtract 5 and you get the next term, which is 90. And it's like going around a spiral, you're getting all those. Now, here in Western Australia, we'll have over and over again to write the formula. Sometimes they'll confuse people and they'll say to write it in the form Tn equals A plus B, BD, they could write anything. Talking about different forms of it and saying get the values for A and get the values for B. They could write anything they wanted to. The interesting part is you get something that you're not used to seeing, you're talking about formula anyway. You get no choice but to go back to the formula unless it said write it as a recursive. Now, one of the advantages here in WA, if you write it as recursive, you can use it in your class pad and you can just get the answer from using your class pad. Let's go back to this. Formula. We have a waste formula sheet here which is allowed to use in all assessments in year 11 and 12. And on the formula, it will say Tn equals A plus n minus 1 d. And that's our formula when we're talking about arithmetic progressions. And if you have a look at the formula, we have a starting value and we have a common difference. So go back to this question here. The starting value is 5. Now what's interesting about it, this system here you had to say the first term, but this system, the first term's built into the formula. So what's the trap? When it's formula, it's built in. So this only uses T once, T 3 times, and T once. Sorry, I'm nagging about it. N minus 1 times the common difference. So I should get that out of the way because it's mucking my brain up. We're adding 2, we're adding 2, we're adding 2. So each time we're adding 2, and that's called the common difference of 2. The rest is just a bit of algebra. So what have we got? We've got 5 plus, what's the trap? It's 2 times n. And then it's, I'm going to say it this way, minus 1 times 2 is minus 2. Then you have 5, take the 2, which is 3 plus 2n. This is the formula for that progression, we're going to say series. For that progression, that's the formula. But if we write it recursively, that's what we write recursively. So recursive writing, formula writing. Back to this one, most you could switch off now and you probably know what you're doing. Formula, so Tn equals A plus n minus 1d, and you can see that A is written in the formula, which is 100. So it'd be interesting, by the way, if that started with 50 and went down by 5s, it just becomes a 50 there instead of a 5. This one now, what's a trap? I saw students write in this latest assessment, they would write that D was minus 5 and they'd write that as minus 5. And it's not really subtract 5, it's actually multiply by minus 5. So maybe that would help if you wrote a little minus up the top there. Let's have a look at what we've got. We've got 100. Now, what have we got here? Minus 5 times by n. Minus 5 times by n, so that's minus 5n. And then the old 2 negatives make a positive. Minus 1 times by minus 5 is positive 5. And your formula is 105 take 5n. So that's formula with 1t. We're recursive with 1, 2, 3 T's. Oh, I hope it helps. Thanks for watching. See you in the future.